We will now continue our discussion of section 8.5 by looking at two additional examples of vectors in the Cartesian plane. Our first example asks us to find what is called a unit vector. A unit vector is simply a vector that has a magnitude of 1. So our example says, let V have the vector representation negative 5, 3, and we want to first find a unit vector pointing in the same direction as V. I have a formula listed here that will help us to find that unit vector in that corresponding direction. Our formula says to find the unit vector, we take our vector V and divide by the magnitude. So the first thing that I need to do is I need to calculate the magnitude for vector V. Remember that that can be found by taking the square root of your horizontal component squared plus your vertical component squared. So in the case of our vector negative 5, 3, our A value is negative 5 squared, and our B value is 3 squared. Negative 5 squared is 25, 3 squared is 9, and adding them together we get 34 underneath the square root. So now that we know that our magnitude is the square root of 34, we can plug in and actually find that unit vector. So what I'm going to do is I'm going to take this vector representation that we have, this negative 5, 3, that is my V, and I'm going to divide it by the square root of 34. So essentially what we're doing is we're dividing each of the components by the square root of 34. So our horizontal component becomes negative 5 over the square root of 34. And our vertical component becomes 3 over the square root of 34. And our book does not rationalize this denominator, although you could by multiplying top and bottom by square root of 34. And so this will be the unit vector that has the same direction as the given vector that we started with. Part B asks me to find the linear combination of I and j that is equivalent to V. This is bringing into play the concept that we can take a vector and write it in what is called an I-J correlation instead of writing it in this component notation that we have been talking about. The I is a measure of the horizontal distance, and the j is going to be your vertical. So if they want us to take vector V, and I'm just going to squeeze this in right here, if they want us to take vector V and write it in I and j form, then all I need to do is I need to say that my horizontal component will be the negative 5. So I'm going to write that negative 5i. And my vertical component will be the 3. And so this is going to be 3j. And so this is all they're asking for. They're simply saying put it in I plus j form. So we'll have negative 5i plus 3j. It's just an alternate way to write that vector. Our next example says that a baseball is hit and leaves the bat at a speed of 100 miles per hour and at an angle of 20 degrees from the horizontal. Express this velocity in vector form. In some cases, information about a vector's magnitude and its angle with respect to the positive x-axis is given to us. In that case, we have a format for writing this as a vector. And that format tells us to do the magnitude of our vector, which we'll call V in this case. And then we're going to have cosine of our angle, comma sine of our angle. And so by using this format or this formula, this allows us to take a situation like this, where we know the speed of 100 miles per hour and the angle of 20 degrees, and plug in and come up with a vector representation for what's happening. So the magnitude is the same as the speed. And so the magnitude of our vector is going to be 100. And our angle is 20. So I'm going to plug in a 20 for both of these theta values. And then we simply need to go to our calculator and evaluate. So I'm going to do 100 times cosine of 20 degrees. And you do want to make sure that your calculator is set to the degree mode. And that's going to give me 93.97 for my initial first component. And then I'm going to do 100 times sine of 20. And that's going to give me 34.20. And so this vector is going to represent what's happening with that baseball when it is hit with a speed of 100 miles per hour at an angle of 20 degrees.